people do get a little confused, and we will try explaining this quickly again. So this is what we are explaining is called algebra of events, and this is where a little bit confusing, and we will try understanding this. So algebra of event is like the we are talking about just like addition, subtraction, multiplication. So there is like what all operations you can do with the events. And the very first event is what we call as complementary event. Complementary event. So what is complementary event is like if you've got an event A, for example, then A complement you write this way, or you write it this way, or you write it this way. These are all called complementary event. So what is a complementary event? So let's understand from sets perspective. And this is the Venn diagram I'm drawing. So this is what I'm drawing a set A, and same way I'm just taking that getting an even number is in my example here. So 2, 4, 6 will be the elements here. This is what is my set A. And my sample space is actually having elements, all the elements 1, 2, 3, 4, 5, 6. So 2, 4, 6 I've shown here. So 1, 3, 5, I'm just showing outside somewhere. Okay. Doesn't matter where I'm showing. But this is what is the representation of a set A and the sample space S. Now, if I'm talking about a complementary set, what I'm meaning is that all the elements which are there in sample space but not in A, when not A. The complementary event is also called not A event, as in I mean, I am okay with everything which is not A. So when someone says when A event here is, for my example, I'm having 2, 4, 6, then my A complement is actually equal to what we call it as S minus A, meaning that all the elements which are there in sample space S but not in A is called complementary event. And in this case, this will be 1, 3, and 5. Do this. So we have got 1, 2, 3, 4, 5, 6. So, and then if you're subtracting, why am I getting it wrong with it? So I'm checking one, is one in there in A? No, it's not there, so I can write it out. Then 2 is there here, so I will not write. 3, I'll check here, it is not there, so I can write it down. 4 is there, so I'll not write. 5 isn't there, I will write. 6 is there, I will not write. So by representation, what we show, like if you want to show, for example, I'm just going a little bit further. I'm not talking about, I'm just going to sets now a little bit. So say this is your set A, this is your set B. So I'm saying a set A is say having elements like same thing, says 2, 4, 6. And then my set B is having elements like say 4, 5, 6. This is what it is. So when you're representing, how you will be representing this as 4 and 6 would be over here because this is common to A and B. 2 would be over here because it's not in B. And then 5 would be here because that's not in A. So this is a representation we call as a Venn diagram. Now, if someone is telling me what is A minus B, all I'm looking for is that what is in A but not in B. So whatever is common shouldn't be taken because that is also in A and B both. So A minus B would be actually equal to 2 if you look at. Similarly, if you're looking at B minus A, if someone is telling you subtract B and A, so B minus A would be, can you, what is in B but not in A? Can you tell me the elements which is in there in B but not A? So this is read as A but not B. This is read as but not A. 5 it is, right? So how do you do it? By doing the picture here, or you, so this is the part which is called B minus A. Okay. This is the part which is called A minus B. And this is the part we'll be learning. The common part is what we call as A intersection B. Both of them together is A intersection B. So you can draw the picture and do this, or you can look at this also, what I did just now, I mean earlier. So B minus A, how do you look at? You will be writing first B first, 4, 5, 6, and then you will be writing minus A, which will be 2, 4, 6. So you are saying it's there in B, but A में नहीं होना चाहिए. B में है तो ठीक, but A में नहीं. So you will be looking at okay, it's 4, 4. You pick up 4 and then that's 4. 4 B में है and A में, so I'll not take. Then you check P 5. You check 5. 5 is there in B, but is it in A? No, it's not there. So I'll write it down. 6. It's there in B and also in A, so I'll not write down. Okay. there is one related concept here I will just talk about. So, uh, see, a minus b, when I'm saying, it is also written as something like this. Uh, this is what actually I'm just jumping to the next part, which is called a but not b. This is what is the case here. A but not b. So a but not b is basically you can write it as a minus b, or it is also written as we write it as a intersection b complement. Okay. So A intersection B complement is same as this. So what we are saying here is that A minus B is also equal to A intersection B complement. So let's talk about B complement. We just looked at A complement, right? So in the same event which is there, my sample space is, say I am throwing the die 1, 2, 3, 4, 5, 6. Sample space. Now your set B, in this case, this is what the example we'll be taking is 4, 5, 6. If I'm talking about B complement, what did I say? B complement would be actually S minus A. So what will be S minus B? So 1, 2, 3. So this is your B complement. What is your set A I'm describing as? So my set A is described as 2, 4, 6. Okay. Now, do you know how to take the intersection? So we are done here. So this is what we are having. Now let's look at our A minus B means separately. So this is what we're saying, that is A intersection B complement. Let's look at A minus B separately. So our A is 2, 4, 6. My B is 1, 2, 3. Now what will be my A minus B? What do you read it? A but not B. So what is an A not B? 4, but I not 3. Okay. So I just took the B wrong. B was 4, 5, 6. Good. So can you see this? This is equal actually. A intersection B complement is actually equal to A minus B. So this is what we call as A but not B. And so this is an event which is called A and B. So let's look at this. So, I mean, though I explained you using the set theory, but let's understand what we mean. So when we say complementary event, right? We complementary event is not A. So when we say that when we throw a die, I'm saying that A shouldn't happen, right? So if 1 or 3 or 5 comes, so I can say that if 1 comes, then I can say that definitely A has not happened, because A will be happening only when 2 or 4 or 6 will. So we'll say that definitely A has not happened. 5 comes, definitely has not happened. So this is the meaning of A complement, meaning that if if A complement has happened, then I can be sure that A has not happened. Okay, so that's the meaning of complementary event. Now A but not B. What is the meaning of A but not B? Meaning that it means that there are two events which are A and B. So if I say A but not B, meaning that A has happened but B has not happened. So what is the meaning here? If 2 comes, then we'll say that A has happened but B has not happened because B is 4, 5, 6. When 4 comes, what can I say? A has happened, B has also happened, right? Because 4 is come, right? 4 is both in both the events, right? Okay. And then 6, if I get a 6, what can I say? A has happened and B has happened both, right? So when I say A but not B, meaning that I am looking at certain thing which is there in A but not B, meaning that if 2 comes, then I can say that event A has happened but B has not happened. All right. If 1 comes, what do I say? If 1 comes, if I throw a die, what do I say about the event? Sometimes they will give you as well. They say that neither A event has happened nor B. So it means that either one can come, then also we'll say that neither A nor B. If 3 comes, also we'll say that neither A or B, right? So neither A or nor B, meaning that I'm looking at the elements here, which is here. So sample space 2, 4, 6, 5, 1 and 3 here. So the by look of it, what we are saying that neither A nor B, meaning not A and B, right? So these are the elements I'm talking about. So if 1 and 3 comes, then we will say that okay, the neither A nor B has happened. Okay. When looking at this, when 4 or 6 comes, we what can we say? If 4 comes, what can we say is just now we said, right? We will say that A and B both has happened. 6 also comes, then we'll say that A and B both has happened. And that's what actually we are writing. When we are writing A and B, what we are meaning is that A intersection B. And in this case, if I take the above example, A is actually 2, 4, 6. And then your set B is actually 4, 5, 6. And then if I say that A and B both have happened, meaning that A intersection B is actually 4 and 6. So if 4 comes, we'll say that both events have happened. If 6 comes, also we'll say that both the events have happened. And how do you represent it in the Venn diagram is, you will write it like this, A and B, and then you will have 4 and 6 over here, right? And then 2 over here, and then 5 over here. And this is what is your common one, A and B. Called A or B. And how do you represent A or B is A union B. So first let's write A union B and then in set theory. What is gonna be A union B here? 2, 4, 5, 6. Okay. And how do you represent it here as this is how you will be representing. So this is your 2, this was your 4 and 6, this was your 5, A and B. So this is what is represented as A union B, this entire thing. So A union B meaning if 2 comes, we say that either A or B has happened. This is what is also called either A or B. Or sometimes we also say that at least A or B. So any of this, the same meaning, as in either A or B. If 2 comes, we can say that A has happened. If 4 comes, we said okay, A and B both. So here that is what was confusing in the last example. Like uh, A and B is also included in A union B. Okay, so that's the reason we say that either A or B and A and B both. If I say it means the same thing. Even if I say either A or B, it means the same thing. So if it since 6 has come, B has happened. So either of 2, 4, 5, 6 comes, right? We will be saying either A or B has happened. I can say for sure. If 2 has come, A has happened. 6 comes, B has happened. All right. Or 4 and 5 comes, A and B both have happened. Meaning that at least A or B happens, meaning either of this comes. If 1 comes, then we'll say that neither A nor B. If 3 comes, we'll say that neither A nor B. Neither A nor B, when I'm saying neither A nor B is written like this. A complement, not A intersection, B complement. Neither A nor B is written like this. Uh, and this can be also written. We know what is neither A nor B. We know that this is 1 and 3. So I am just showing you these are all equivalent. So neither A nor B meaning that this and this both. This is also represented as A union B complement as well. So these are very important results. So we will look at them again. So A intersection B, this is what we call as the De Morgan's law. So De Morgan's law says what? There are two things only De Morgan said when you learnt about set theory. He said two things. One is this, what I just mentioned, that A union B complement is actually equal to A complement intersection B complement, or A intersection B complement is actually equal to A complement union B complement. So what is happening here is that there is a union here and then whole thing is a complement. Then this is equal to A complement and then union changes to intersection and this individually it comes to B complement. Here A intersection B complement becomes A complement union B complement. So what you can do is there are several things you can do, and that's what actually I'm trying to explain in using various things here. So, what you're understanding, neither A nor B is this. This is what you're understanding. A union B complement. What is the meaning of A union B complement is this is S minus A union B. So that's what you were looking at, right? So what you were looking at that A or B has not happened, right? And then if I subtract it from 2, 4, 5, 6, right? I will get 1 and 3, right? Here. So any set's complement is what? So you can subtract it from the sample space. So sample space is 1, 2, 3, 4, 5, 6. Your A union B is 2, 4, 5, 6. When I subtract, I will get 1 and 3, right? Okay. Actually, this will also be equivalent to this. If you look at this, A complement is what? 5 and 3, 1, 3, 5. Let's write this. What is B complement? Complement intersection B complement. So you can see neither A nor B is can be expressed like A union B complement as well. What you're looking at is that first you're saying that either A or B, neither A nor B, meaning that both of them have not happened, meaning that uh, either you can write it like this, visually understand this, and then write it over here 1, 3, or you can use the formula this, or this, right? Anything is fine, whatever makes sense to you, depending on the situation. Okay. Hmm.